due to infinite sheet charge. Okay. So we have seen electric field intensity due to infinite line charge. Line charge means we are considering one line where the number of charges are distributed. Now here we are considering infinite sheet. Okay. For this purpose, consider a Cartesian coordinate system first. Okay. Now here we are considering one sheet. Sheet means we are considering one surface. Okay, one surface. That is a conducting surface because the number of charges are distributed on that surface. So here we are considering a cylindrical coordinate system to represent the coordinates. Okay, so x, y and z, these are Cartesian coordinates, and a sheet is placed in x and y plane. Okay, so So consider this is a sheet or surface. Now this one is placed in x and y plane. X and y plane means where? X and y plane means where? I am telling sheet is placed in x and y plane. Means where? At ground or at vertical? Yes?
Ground.
At ground,
Ground.
correct. In x and y plane means at ground. Means what? The z component is 0 here. Now if I consider that there are different charges, right? Number of charges, and if I consider a small piece of this surface, this small piece is ds, and if I consider the charge in that small piece is dq. Okay, dq. Now if I am considering, or if I am applying it by considering the cylindrical coordinates, then what are the cylindrical coordinates? So what are the cylindrical coordinates?
R, phi and Z.
R, phi and z. Okay, R, phi, z. Now I am connecting this origin to this point. Okay, having differential surface area, yes. Okay, having differential surface area, yes, ds. Okay, now this is the small distance r. Okay, this is the small distance r from origin to this point. Okay, and I want to find electric field intensity. Now already this sheet is placed in x and y plane. Okay, so I'm considering the point P on z axis. Okay, means electric field intensity at z axis. So to find this, just connect point P to point dq. Okay, and this is a straight line. Draw it straight line because on slate I cannot draw correctly. I think you all know about that. Slate is difficult to use. So what will be the direction from P to ds? Yeah, from ds to P. Yes, we have to find electric field intensity at point P. Then what will be the direction?
DS to P.
ds to P, correct. So this is direction. Now the distance is considered r here. Okay. Now tell me what is r bar. First of all, we have to find this dq. So what will be the dq? Yes, dq for sheet charge. Okay, first tell me what will be rho for sheet charge density is denoted by Yes, sheet charge density or surface charge density is denoted by rho,
Rho
Rho
yes.
S.
rho s, and this rho s is equal to limit
Limit
as
delta S tends to 0.
0 of delta q
Delta Q
upon
upon delta S.
delta s. Correct. Means this dq, how I can write this dq? Dq is equal to rho s into ds. Correct. Now I want to find this ds because the differential surface area is different for every coordinate system. We have seen that. So what is the differential surface area for this sheet? What will be that surface area?
DS.
Yes, that surface area is ds, but here we are placing one sheet. We are placing, imagine, we are placing sheet at ground floor, right? At ground floor means that sheet is in xy plane, but here we are considering the cylindrical coordinates. Okay, we are considering one cylinder. Okay, you can simply consider a base of cylinder. Okay, base of cylinder which is placed in x and y plane only. Then if base is there which is in only x and y plane, what will be the constant here? Z coordinate will be constant. I'm giving you clue so that you can answer easily. Then if Z is equal to constant, what is the area? What is the surface area for cylindrical
RDRD
coordinate?
5.
It is RDRD phi. Okay. So everyone tell me, is that differential area is correct or wrong?
Correct, ma'am.
How? Is this RDR and D phi
DR into RD 5.
or it is RDR into RD phi?
DR into RD 5 R आधी घेतलं मॅम.
Ha, correct. Yes, you are right. I want to ask to others. Yes, is it correct? And why it is only dr into RD5? And why dz is not there? Yes,
Z is constant.
because z is constant, we are placing this sheet only in x and y plane. That's why it is rdr d phi. Or for r it is dr, differential length is dr, and for phi the differential length is r d phi. Therefore surface area is r dr d phi, and if we are taking vector differential surface area, then we have to multiply by the unit vector which is perpendicular to this plane, that is a bar z. Okay, here for this case. So this is, we get here ds also. So I can write equation for this de de bar is equal to, or first I'll write equation for only e so that everyone will understand. So equation for electric field intensity E bar is equal to, this E bar is equal to Q upon 4 pi epsilon 0 r square into unit vector A bar r. Now if we are considering the differential for only this small surface, then it is d E bar is equal to dq upon 4 pi epsilon 0 r square into unit vector A bar r. Okay. Now this dE bar is equal to, now dq is equal to, dq is equal to rho s into ds. Here it's already given, dq is rho s ds upon 4 pi epsilon 0 r square A bar r. Okay, I think first we need to find this r and a bar r, right? So find vector r bar. Now tell me coordinates of this ds for cylindrical coordinate system. For cylindrical coordinate system, what will be the coordinates at point ds? Is there r present? R is present or not? Hello? Yes, R is present or not? First tell me. At point ds. Hello? आहात का सगळे? आवाज ऐकू येतोय ना? हॅलो? Am I audible to all? Yes or no?
Yes, ma'am.
Then what's about answer? If you don't know, at least tell me we don't know. Yes. First coordinate. Is R present? At point ds. Is R present? Radius? Yes or no? R आहे का इथे? R is present or not?
Yes.
Huh? Revati, roll number 13, Revati. Is R present? Revati? Almost 25 minutes. Do fast. Okay, is R present? Yes or no? Okay, so here already R is given, right? Up to this point, it is the distance from origin to point ds, means R is given, so R is present. Now what's about phi? Phi is the angle from x-axis. So is phi present? Phi is present or not? Hello? Yes, means phi is also present. And what's about z? Is z present at point ds? Yes or no? Answer fastly, because huh? No, because this sheet is placed in x and y plane only. Therefore, z coordinate is 0. Okay. Now tell me the coordinates of point P. Is R present there? R is present or not? R means what? It is the distance from origin to this point. Now point is placed in x and y coordinate only. Is it placed in z plane? No, it's not in z plane. It's only x and y plane. Therefore, the r coordinate will be 0 here. Now phi. Now this phi varies from 0 to 2 pi and it is along z axis also, right? It's along z axis also. So at point P also this phi will be present. And what about the last coordinate z at point P? Z is present or not? Yes?
Present.
Present, because point P is placed on z axis only. So the z point must be present there. Okay. So the coordinates of point P are 0, 5, z. Okay. So We are going from this ds to point P. We are finding electric field intensity at point P. So direction is this one. Okay. So find R bar. R bar is end point minus start point. Means this is R bar P minus R bar ds. Okay. So it is 0 minus r into unit vector a bar r plus second coordinate is phi minus phi into unit vector a bar phi and plus last coordinate is z minus 0 into unit vector a bar z. So this r bar is equal to minus r a bar r. Then phi will become 0 here and last coordinate is z into unit vector a bar z. Again find this mod of r bar to find magnitude. Okay, so mod of r bar is equal to square root of minus r square plus z square. Okay, so this mod of r bar which is equal to r is equal to square root of r square plus z square. Okay, so we get here r. Now we have to find unit vector in direction of r, that is a bar r. That vector is equal to, unit vector is equal to vector divided by its magnitude is equal to, vector is minus r a bar r plus z a bar z divided by its magnitude is square root of r square plus z square. Okay, so this is unit vector a bar r. So we have to put all these values in equation of this dE bar. Okay. So this dE bar is equal to, everyone is getting this point? Yes or no? It's simple. We have to only
Yes, ma'am.
find unit vector. Okay. So this dE bar is equal to, dE bar is rho s into ds. Now rho s ds. Rho s will remain as it is. But what is ds? The differential surface area. That is r dr
RDR D5.
d phi. Correct. So it is r dr d phi divided by this 4 pi epsilon 0. Now r is equal to square root of r square plus z square. Can I directly write it as only r square plus z square? Because again we are taking its square. So square root square means it's only r square plus z square. Okay. And unit vector is minus r a bar r plus z a bar z divided by again square root of r square plus z square. Okay. So everyone first note this point. Okay, when you finish your write up, tell me. the practical applications of